All right, in this video, what we're going to be doing is putting in all of the tier supports for supporting this multi-tier configuration. And this is an involved video, wouldn't you say?
Yeah, there's quite a few things going on here. A lot of stuff that's in preparation for actually creating our tier supports, and a few little bits afterwards since we're finishing up our entire tier system. I want to add a few extra little things on the end, and we're going to cover that in this video as well.
Okay, so the idea, of course, is just to get this crisscross pattern between these tiers.
Sort of like a crisscross pattern that comes across between these tiers, either edge, and then again, once we start getting multiple towers going across and things, we're going to have those in the centers as well.
Okay.
So, yeah, it's a little bit in depth.
So this is one of those, where generally I say, all right, Steve, well, how did Peter tackle this? But you can't really throw out a fast answer, can you?
The fast answer is watch the video, really.
By doing a bunch of stuff.
There's a lot of stuff going on. Very simply, it's creating the curves that define our crisscross, and creating surfaces from those curves and copying them across. That is the very quick and simple answer.
That sounds brilliant. Right.
But it's actually a lot more in depth than what I just said.
Okay. So let's put it together.
Yeah. The first thing I'm going to do is going to seem a little bit random at first, and that is I'm going to set up a system where we can control the detail on our tier surface. Currently, we just have one division in width and one division in length. The reason for this is partly because it's nice to be able to control detail on a surface, but the divisions in length is also going to be used to control how many crisscrosses we have in length. So I need to set this up now so that we can utilize it later when we're setting up our crisscross tier supports.
Okay.
So I'm going to jump over to our master control node and bring up our parameter interface. And before I do anything else, I want to start rearranging these into a more logical order, because I think the number of tiers is probably more important than the thickness of the tiers, so I'm going to put that above that. So I'm going to set up a new toggle, and this is basically going to let us switch between using the number of divisions we've got currently. And that's going to change up slightly later when we start bringing in towers and things as well. For now, it's just a single division in width and length. Or do we use our override for changing those divisions and then changing the amount of tier support crisscrosses we have? So I'm going to bring in a toggle. And I'm going to rename this guy to tier division override. And very original label of override tier divisions.
You got a period after the tier?
Yeah, because that's abbreviated, don't you know? So, yeah. Okay. And I'm also going to drag out a integer vector 2 because we're going to deal with a length and a width.
Okay.
Once we drag this guy out, we then have the ability to horizontally join to the next parameter. When this is the last parameter down there, we actually don't. I'm also going to drag this up underneath our width and length, since it's logical for this to exist before our number of tiers. So I'm going to rename this to tier subdivisions. And set the label to tier subdivisions. So integer vector 2. I'm also going to set our range. I want to make sure we have a minimum of 1, since we want to have at least one division in width and length, and a maximum of 20. But I'm going to leave that unlocked. So that's just so our well, in actual fact, we're not going to have sliders here, but still, a maximum of 20.
Okay.
I just think that might be possibly redundant, but never mind. It's fine, there's no harm in setting it. So we do want to disable this guy when we're not overriding tier divisions. So we've already seen this before. If we use our tier division override, when that's equal to 0, this guy will be disabled. So we accept that. So override tier divisions is on, and we can see this guy. If we uncheck that, he becomes grayed out. I'm going to set some default values, 12 in length and 5 in width, just so we can see this working when we set up our lines. So I just mentioned before briefly, this length is going to also control the number of crisscross patterns we're going to have, so it's worth keeping that in mind, and that's why this is being done in this video.
Right.
So if we come over to where we don't put a space in the name there, thank you. We come over to where we're copying, I'll grab this guy, bring him with us, where we're copying our length curve and our width curve to grab all these nodes. There we go. Let's actually maximize this guy. We see what we're doing. This is where we're copying our length curve to our width curve to our length curve, and then we're skinning that surface. Just before here, if we have that toggle checked, I want to resample the curves so that we increase the number of points, so that there's going to be more points on them when they're copied, and that's going to result in more divisions in our skin and all our surface that's generated from that.
Okay.
So I'm going to branch off of our length by middle mouse button and drop down a resample node, and we are going to then switch between these two on the input. But first, if I tap P, bring up some parameters for this guy, and also rename the node to resample tier length. So I'm not going to basically, let's actually see, what does this do? So we have maximum segment length currently. Turn on point numbers. The using length basically controls the length of the segment before we jump on and create a new segment. I actually want to do this based on number of segments, since this is something we actually know. And we can grab that from our master control, which is hiding over here. So if we grab tier subdivisions X, and use that to control this guy. So now, if we were to change this on our parameter, that's controlling the number of divisions in the length curve. So, between our length scale and our copy, I'm going to wire in a switch node that I can then feed this guy into. So if we right click and drop down a switch, and wire that into the switch, we're currently set to select input 0 being our first curve. If we select over to 1, we're getting our resampled curve, so we need to drive this based on the toggle value we just set up. So this toggle value, when it's off, we want to use the original curve. When it's on, we want to use this curve, which is set up very nicely with the order of the switch we have currently. So if we copy that parameter, and we can paste that guy as the switch input. So if we jump back over here, if we're not overriding, and then if we are overriding, this guy is going to control.
Very nice.
So we're going to set up the exact same thing with our width curve. So we take the switch here where we've got our width curve set up, and I'm going to branch off of that with a resample node, which I will call resample tier width, and uncheck max segment length, check max segments. Let's bring our master control where we're working so I don't have to keep navigating to find him. Copy this guy, which was our second input on our tier subdivisions, and paste him down onto here. So just to show that that is working. So there's that parameter being used to drive the number of subdivisions of that curve. And again, we can wire a switch in between these two. Just drag him over to the side, wire him in, and then use our override toggle to drive the switch input. So now if we are overriding, we're getting detail controlled by that guy, and when we're not overriding, we are getting using our original curves, which currently have one division in length and in width. That will be changing up shortly. So we now can actually move on to setting up our crisscross tier support pattern. Let's bring our visibility down to where we can see our multiple tiers, and I can maybe explain the direction we're going to take with this. We have, if I also grab our master control and override tier divisions, we've got these divisions running along in length, and what I really would like is basically a diagonal line that runs in length for one of these divisions, and runs in height from basically in between the two tiers, so that we have a diagonal line that's running across from one tier down to the other, that's length is controlled by this division set up here, so that when we change the number of divisions, we'll get a different number of those crisscross patterns. So the way I'm going to do this, the way that Peter did this, was to basically create a new line node, and set the translate Z positions of the 2 points on that line to the translate Z positions of the first and second point, so point 0 and point 1 of this curve we've just resampled. and to set their Y positions to the height curve that we use to copy these down. So that's what I'm going to do now. And first things first, I'm actually going to branch off of our resampled length curve, so where we're switching between the original or the new one. And I'm going to branch off of that by middle mouse button. I'm going to drop that into a delete node. And we're going to use this delete node to delete out everything except for the first 2 points. So if I bring my visibility down, we're currently dealing with this line here. So I want to delete the non-selected and change our entity down to points since we're dealing with points. And let's change our pattern to 0, space 1. So 0 and 1 are the selected points, and we're deleting the non-selected points. That's going to delete everybody but 0 and 1,
okay.
Which gives us just one line segment that is the correct width for what we wanted to deal with. So we can now create a new line and set its translate Z positions based on these 2 points. So let's drop in a new line. I'm actually going to leave it at default settings. I will rename this guy to, I'm thinking tierSupport baseline maybe.
Okay.
And we can wire this into a new point SOP. Now the point SOP basically lets us set up attributes, change parameters of our individual points. It evaluates on a point-by-point basis. So currently the position of these points is set to their existing position. $tx is a local variable on the point for its x position, $ty likewise for its y position, and tz for its z position. Now the great thing about the point SOP is we can wire in a second input. And with our second input, we can basically reference the attributes of the points that are coming in the second input. But it's basically for the same point number that we're currently looking at. So here we've got points with 0 and 1. Here we're dealing with a point with 0 and 1. So when we come in and we're dealing with point 0, if we were to reference the second input, we deal with point 0 on the second input. When point 1 comes through here and we're dealing with point 1, and we reference the second input, we deal with point 1 up on the second input. So what we can do, we can change our position Z. Instead of using the current position Z of the point from the first input, we can use the position Z of the point on the second input. I'm actually going to take the negative of that. So our line comes in, and its position Z is Y and X stayed the same as before, but its position Z of 0 is taken from the position Z of the 0 point coming in from this delete node, which was at the origin, and its position Z for point 1 is the inverse of this position Z. The reason I've gone with the inverse is just the way that we're setting this up. Could have gone either way, but I've chosen to take it this way. I'm then going to shift everything along when it's copied and ignore this first point when we copy. If we'd gone the other way, we just ignore the last point when we copy along. So it's just basically a matter of preference with which direction we're taking that. So we've got this guy set up with position Z. I am going to call this point transfer Z, just so that in my mind I know what this guy is doing. And we now need to do the same thing for our height curve. So I'm going to find where we switch between... Where are you hiding? That's funny, it's already becoming crazy. I am hunting...
Feel free to maximize.
Yeah, that really would be helpful. It's down here. So we've got we're switching between a single point and our line that has multiple tiers. So I'm going to branch off of this, since this is going to be dealing with our tier system. I'm dealing with the final curve that we use for the tiers. I'm going to branch off of that again with a delete node, which I will not zoom out that far because that was crazy, and bring this delete node down where we're working. And if I set the visibility to this guy, we could come over to delete non-selected again as before. We're dealing with points as before, but our pattern again is also going to be 0 and 1, so that we're dealing with just the first 2 points on that curve. So we can, before I use this and transfer the Y positions over, currently this goes from the top of this tier down to the top of the tier below. I want to offset based on the thickness of this tier. I want to grab one of the points and move it based on the thickness of this tier.
Okay.
So the way I'm going to do that, I'm going to basically group one of our points, and I'm going to then put a transform node on that moves that point.
Okay.
So let's drop down a group node, and let's change our group to deal with points. I'm going to call this group point 1, and I make it a habit of renaming my group nodes to the name of the group that they're creating. So we'll name that group point 1, just so that you know if you're seeing group point 1 further down the network as a group that's available, you can quickly identify which node is actually creating that group. So we'll set that up for group point 1, and we're going to be grouping by pattern, and the pattern is going to be 1, so we're simply grabbing our second point there. And then we can wire this into a new transform node. And with this transform node, we are able to specify a group to work on. We'll work with group 1, which means that now when we translate in Y based on our tier thickness, we're only going to be affecting that single point. So we can take our translate in Y and set that to master control, tier thickness. And that will offset that point based on the thickness of the tier. So the curve is now basically the height of the gap between the bottom of one tier surface and the top of another tier surface. So with that in place, we've transferred over our position in Z from the curve that was running in Z. So now let's do the same thing with our position in Y. So rename that guy, wire this as our second input, and if we simply come down here, I'm going to take ty, I'm going to take the negative of ty, and we're dealing with our second input, so if we add a append a 2 to the local variable, that's referring to the second input's local variable for that. So now we have a line that's set up such that we have what we were after. It's in Z, it's the length of one of our divisions along our tier, and in Y, it's the distance between the two tiers. Did you want me to demo that by changing some of the parameters? Yeah. Sure. If I was to template this guy, kind of get an idea, and then if I was to find our master control, so if we change our tier height, which has exploded. Okay, that's great. Tier length hasn't exploded. Tier length works. I'll go and fix tier height in a minute. And these number of divisions is also changing. If we were to not override that, we get a complete length for our curve. So that's,
that you can tell is about as long as the entire tier.
Yeah. I'll tell you how we could demo this. I'm wondering if our tier number is broken as well. Sweet. Let's get this fixed up, because that is an issue. So, enter, enter. So frustrating when that breaks, but again, we are still working with a beta version of the software, so it's working nicely, and
very nice.
Tier height is working nicely. So, if we continue on from there, we've got our single curve in place. So, let's now set up another curve, which basically is a flip of this guy, so that we've got our little X in place. So, I'm going to wire our latest point node into a new transform, which I will rename to xform flip. Bring our visibility down to this guy, and I'm going to set up our pivots to some local variables that are available to us. These are the center of the, it's a centroid in X, Y, and Z, which is basically the center of the geometry. If you bring up the help file if you want to.
No, that's okay.
That's fine. I don't know how much detail to take that into. So, yeah, it's basically the center. We can see the pivot here.
It's now at the center.
Now the center of our line.
Which will work for scaling negatively.
Yeah, so if we scale negatively based on the center, we're going to basically flip this guy over so that they cross at the center. So we can take our scale in Z and set that to -1.
Very nice.
So now we've got a crisscross, which we can wire these two guys down into a merge. Oops, I meant to middle click there rather than right click. So now we've got those two lines. I do want to get a third line that runs down vertically straight down. It's going to basically generate a pole that goes in between each of our crisscrosses. So for that, I'm going to branch off of our I'm trying to remember where that line exists in our network.
Yeah, that's the lovely thing about having such a large network, is how easy it is to get lost.
We just took a line and used it earlier. There we go. We took this line and transformed it, which is the height. I was thinking about the height again, and my mind had wandered back to the original height curves, and actually I needed to be dealing with this guy. So, yeah, this curve is actually going to work perfect for that end curve we needed, and he was right where we were working currently, which is great. So we can take this guy. I am going to branch off and wire him into a new transform, and with that transform I'm going to flip him in Y. So we can take our scale in Y and set that to a -1. And what that will do, that'll flip him up, which we can now take this guy and wire him into the merge also, giving us a crisscross pattern.
Very nice, very nice.
Awesome. So with this pattern in place, we can create a wireframe node, and what that's going to do is going to basically turn these single lines into a tubular type geometry. So we can take our merge and wire that into a wireframe node. I do want to uncheck round corners, since these will actually be sitting up inside of our tierSurface slightly anyway, and there's no need to add that extra detail there. I am going to set up a control for our radius, and we can set that up over on our master control. So let's come up here. It's going to be a floating point, which let's drag this down here and call this tierSupport radius. I nearly put a full stop after tier as well. Which I will set up with a range of 0.001 and 0.5, because we are dealing with a fairly small radius there. So let's find where that guy's hiding at, copy him, and use that to drive our wire radius, which currently is crazy small, but we can boost that up a little. I also want to control the detail on this guy, so I'm going to wire our wireframe node into a convert node. And convert node lets us control our level of detail. If we come over to a divisions per span tab here rather than the level of detail tab, and that lets us control our detail in both U and in V. Now in V I'm going to leave that set to down on 1. We only need a single division along in length, but in U I'm going to set up a control for that on our master control.
Okay. So
let's jump back up to our master control, edit our parameter interface, and drag out a integer parameter, which I will call tierSupport divisions, which will give a range of a minimum of 3, since a triangle type geometry is probably the minimum you want to work with. We don't want that to collapse down to a flat plane.
No.
And I'll leave that as an unlock 10 at the top. So we can grab that divisions value and copy him and paste him as a relative reference on the U. So now as we start boosting that up,
I think it might be better if you kind of tumble around. There you go.
So we can see, if we focus on the end of our convert of our wireframe. So there's the minimum of 3. We're dealing with a triangle.
Much better, yeah.
As we start boosting this up, we're increasing the amount of detail, which gives the artist who's using the asset a nice control for dealing with just how much detail he wants in his scene when he's coming to render time. Since these might be very, very small in your render, you don't need much detail. They may be very close in your render and you do want detail, so you have a control up on the asset rather than someone having to dive right down into the network to set all these up. So we got this single piece in place. We now need to copy this guy for the length, and then we're again going to have to copy it for the width. So going to wire this into a copy SUP. And we're going to basically take our length line curve, and we want everybody but the first point. So I'm going to branch off of that with a group node, so we can group everybody but the first point. So let's find our length line. So there's our length, and that's where we're switching after resampling. So let's branch off with a group node, which we will bring down to where we're working. And we'll set up the group name there to group not 0, which I will also set our node to be named that. We're dealing with points there. If I bring my visibility down, you see where we're dealing with points, and I want everyone but 0, so we can set our pattern to exclamation mark, which means not 0, and that groups everybody but the 0 point there, which we can now wire this into our template geometry for the copy SUP. And if we come up to the copy SUP's template group, we can use group not 0. We lose that first copy, which would have been sticking out over the end. So now we've got this nicely copied along for the length. I am going to rename this copy SUP to tierSupport length copy. So now that we've got this guy copied for the length, let's copy him for the width.
Okay.
So we jump up to our width curve where we switch here. I'm going to switch before we resampled this time. The reason is that resampling was changing the number of divisions based on our surface, on our tier surface, but that isn't going to necessarily be how many towers we have, and so we don't want to have the possibility of using this guy. Further up the network, when we start dealing with towers, we're going to be resampling up here to generate the right number of points for towers and things. So I'm actually going to branch off from this point. So currently we're just going to have the 2 copies of these either end. And later, as we start bringing towers and things, we'll get, if we have like 2 lanes, we'll have a third copy in the center.
Okay.
So middle mouse to branch off of this guy, and I'm going to wire that into a new. I actually need to wire that into a new copy, but it needs to go into the second input of a copy. So let's branch that into a copy, and let's bring this down and take this guy and copy him based on the width. So now we have 2 copies this guy either end. So I will rename this to tierSupport width copy. So we have these 2 guys copied for the the width.
Let's go ahead and kill all the point numbers at the moment.
Yeah, that is a little bit crazy.
Much nicer.
So we're dealing with we've got these copied in width. We now need to deal with height. We need to copy these for all our tiers. So let's branch again off of our height curve, where we are switching with either a height curve or a single point. Let's branch off of that guy and branch that into a group node. And I'm going to rename this group to tierSupport group, which again I will use as our node's name. We're dealing with points again. If I just remind everyone of the actual curve we're dealing with, we basically want to group everyone but the 0 point, because when we just have a single point up there and when we have our single tier, we don't need our supports. It's only for every tier after that we do need supports. So I'm going to group, we come down grouping points, and I'm going to use the same pattern as we used earlier, which is not 0, to group everyone but that. So we can drop down a new copy SUP, which we can wire our tierSupport geometry that we've copied for the width into there, our tierSupport group into there, and then set our template group to that group we set up so that we don't have one at the top. So now we got this copied, we can merge this with the tier geometry we've already created. So let's wire this into a merge, and let's find our merge that we were dealing with previously, which was our tier height being copied. So we can wire that down into a merge. So now if we turn off point numbers to speed up our display. We're getting a nice crisscross pattern. Before I move on to some final controls, let's test this out and see how it's functioning.
Okay.
So I'm going to find our master control, which is definitely getting buried. Right, let's grab you. I'm going to push C to bring up color. I'm going to make this like bright green so that he's always standing out. Just because we need to grab him so frequently and he could be anywhere in the network. So let's grab our master control and let's start playing with these and seeing how they're functioning. So if we were to change our number of tiers, which has exploded, thank you, that's just great. So let's tier height, let's enter and enter, and now find our master control, radioactive green. So tier number 3, 4, 5. So
very nice.
That's working in there, changing the scaling and everything of those guys. The lengths of the curves is being used to generate them. The height between them also. Mm-hmm. So, and if we were to change the... Why is everything exploding? That's just frustrating right there.
Oh, it's the joys of recording. Of course that's going to happen now.
Yeah, that is very true. So let's enter you. And since I'm pretty sure that these have probably exploded as well, I'm just going to enter these while I'm here. Alright, so let's find our master control that's back down here. Change our length up. And since we're set to a ratio on our width as well, that's going to be changing our width up. So let's not use a ratio, let's actually use a width control. So if we just change our length, we can see
very
that
nice.
Changing nicely. And finally, let's change our subdivisions to see that controls the number there, and if we turn off our override.
Excellent.
So everything is functioning exactly as we need it to. So I'm just going to set up a couple of like overall controls. We've set up our tier system here. I want to have a control that lets us basically control the length of the tier and the width of the tier separate from the length of the bridge and the width, sort of like a scale, kind of a scale factor. And I also want to be able to translate this in Y up or down to offset it, since you may want to have the tiers at a different location than the default location of the bridge. So let's set up some parameters on the master control. Let's grab a few float parameters. The first is going to be tier length, which I will put after tier height, since that makes logical sense. It's a float with a range of 0.001 going up to 2.
Just go and lock it on the
lock it on
side.
Yeah, awesome, thank you. And exactly the same for width. I thought I was typing in the label. So we can lock this guy to 0.001 and set this guy to 2. And then finally we'll drop a float in, which can be called tier position Y. And I will set up a range on this guy between -10 and 10. So we can now get these in place by wiring our final merge for all of our tiers and everything into a transform. Bring our visibility down to this guy. I will set up our pivot on here also to $CX, $CEY.
Just so that once again it's in the very center of the geometry.
Yeah, so as we scale this based on width and length, we're going to basically be scaling from around the center point, which means that if we've got towers and things on our bridge, we're not going to scale from just one side, we are going to scale from the center point. Now we know that the center point in X is the origin, but it's easy enough just to put in $CEX as the centroid there. So we can set our scale in X will be tier width. So everything's gonna shrink down crazily. So let's boost that back up to 1, and then we can set our scale in Z to tier length. So let's copy U and paste that to relative, and that's shrunk everything right down. But we can boost tier length up to 1, and then let's finally translate in Y based on that position Y offset that we had. So let's grab that and copy U and translate in Y. So now if we take our position Y, we can offset down and offset up.
Very nice.
So with that wraps up a slightly lengthy video, but hopefully everything made sense. Hopefully everything was logical, and you can see why that we couldn't explain in great detail right at the beginning where we're going with this.
Yeah,
so,
that's an awesome job, Steve.
Awesome, thank you.